Hello, everyone, and welcome to the open day for the MSc Computer Science and MSc Data Science and AI at the Creative Computing Institute. My name is Georgina, and I'll be your host today. And we're going to be sharing all about these new two courses that we have at CCI. Both of them are new additions to the Creative Computing Institute, and we're very proud and excited to present it to you today. We'll have with us Dr. Vali Lalioti, who's the Director of Programs at CCI, and she'll be sharing a little bit about the course overview and structure. Then we'll also have Professor Rebecca Fiebrinks and Professor Mick Grierson, who will share some related examples about the research in these two areas. To give you an overview of how the session is structured, we're going to start talking about the Creative Computing Creative Computing Institute first. So we've got some videos that we will play that will give you an idea of all the spaces, facilities, and resources that are available to CCI students. And then we'll also talk a little bit about the research themes that we explore here at CCI and the social mission and public program activities. So after that, we will move on to our Q&A section, where we have gathered some frequently asked questions about these new courses, and we'll be covering them. And during that section, we also encourage you to send us any doubts, any queries, any questions that you have about the CCI or these two new MSCs, and we'll do our best to answer to all your questions. Before we continue, if you have difficulties following along the session, know that the entire session will be recorded and it will be re-uploaded on YouTube with English closed captions. So know that you will have the chance to catch up with all the details at your own pace. So let's get this started. We'll begin by watching a video that will walk you through all the spaces that we have at the Creative Computing Institute, all the resources and all the facilities that are available to all CCI students.
Welcome to the CCI Facilities Tour. Over the next few minutes, we are going to show you around the campus and tell you a bit about the facilities and resources available to our students. CCI South London is located across two buildings along Peckham Road in Camberwell. We share our buildings with Camberwell College of Arts, which is a fantastic opportunity for CCI students to get to know and collaborate with students studying courses like fine art, photography, graphic design and illustration. The Greencoat building hosts teaching spaces and technical spaces for students studying creative computing and creative robotics. It also hosts the Dark Lab for AR, VR and interaction design. This summer, we are going to be creating additional technical spaces in this building to support the new creative robotics courses that open in September 2023. CCI is located on the 5th floor of Peckham Road, where we have teaching spaces and technical labs, as well as a kitchen, which is our main student hangout and study space. We have several high-spec workstation computers where you can work on machine learning and other intense computing tasks. We have a library on site with access to a range of books, ebooks, periodicals, and databases. Our dedicated librarian, Beninia, ensures that these resources are kept up to date to help you complete your studies. Across the courtyard is Gardens House, one of a growing number of halls of residence across London. And on the ground floor is the Learning Zone, a space for self-directed study that is open 24 hours a day, 7 days a week, to all UAL students. There are places to eat, like our canteen, student advice centre and support services, and an art and material shop. In summer 2023, we will redevelop the former London College of Fashion building at High Holborn. We will share this building with UAL's brand new PhD hub, which will help to ensure that CCI's focus remains around the development of world-class research. At our Holborn site, we will create new technical, teaching and library facilities to support our new courses in computer science and data science.
The technicians here at CCI all have a decade of experience doing really cool stuff with emerging technology. We'd love to help the students here with any questions they have about their projects. The Dark Lab is for experimenting with interaction, projection, sound and VR. Great for permanent projection setups. We've got a couple of VR booths. We've got loads of speakers and many other toys to play with. I specialize in creative coding and especially interactive things using Kinect and cameras and game engines, 3D graphics. We have a whole bunch of equipment that students can take out on loan, including projectors, Kinect. We also have laptop lockers where you can get a laptop to work with.
Physical computing really is just the connection to the physical world, to the data. Students have played with physical computing in all sorts of different ways. A lot of interaction with gaming and the VR world as well. Sensing various different bits and pieces, using touch especially, all sorts of different sensors to put things in a virtual world, or vice versa. They could have things coming from a virtual world and bringing them into the real world. We generally lend Arduinos to all of the students, and with that we have a collection of different modules. This allows us to interact with the world in various different ways. Those modules could be sound sensing, they could be image sensing, they could be sensing the environment in some other way. The benches here are for the students to solder and prototype, put different boards together. We have different components with different levels of exploration with electronics, so you can quickly get something together on breadboard, or you might want to make something that's more solid.
I help students who want to use the digital knitting machine, the digital embroidery machine, and who are also thinking about incorporating electronics or computation into textiles or wearable kind of technology. We have a silver reed digital knitting machine. So that's a domestic knitting machine that can be computer controlled, so you can use it to create digital patterns, and that's used to produce knitted fabric. I tend to think of it like a 3D printer kind of for textiles. And then the other textiles machine that we have is a Brother digital embroidery machine. So that's kind of fully automated programmable embroidery machine that you can use to embroider textiles.
This is Digital Fabrication Lab, and we have 3D printing machine and laser cutting machine here. For our 3D printers, we just drag your design into the software and slicing it and directly push it to the printer, and your design will be materialized. For the laser cutter, it's also very efficient. Even very complex pattern, it will only take like several minutes. Most of students will use it to generate the housing for their physical computing things. It helps students to materialize their project quickly.
To find out more about our facilities and equipment, please visit wiki.cci.arts.ac.uk.
Now, a lot of students are interested in finding out more about the research themes that we explore here at the Creative Computing Institute and the social mission that underpins this research, but also teaching and all the public program activities that we run. In the following video, we will share with you all about it.
CCI's key research themes are creativity, machine learning and AI, human-computer interaction and platforms, and big data and digital citizenship. So we're interested in how machine learning and AI can transform people's creative practices, enable the creation of totally new kinds of work in music and art, and enable new people to get involved in creative practice. We've created a lot of software tools like Wekinator, Mimic, and InteractML, which are used by tens of thousands of people around the world to make new music and art and games. We've had staff and students exhibit work that's created with AI at venues like the Whitney and the Barbican, and we've had collaborations with artists and musicians like Arca, Massive Attack, and others. A number of staff and students are also leaders in community and activist groups. For instance, the Code Liberation Foundation teaches women and non-binary people how to make games, and the Critical Platform Studies Group explores how digital platforms might encode and even reproduce patterns of problematic power structures in society. This rich and exciting research environment is the product of many staff coming together from lots of different disciplines. These include not just computer science and art, but music, engineering, design, philosophy, art history, and all sorts of other domains. We all bring our excitement and experience from these different research projects with us into the classroom. And it's a place that I really love teaching, and I'm excited to share it with you. CCI's teaching, research, and outreach activities are all informed by our social mission. This mission has three components. They are digital inclusion, diversity in technology, and digital entrepreneurship. First, we are committed to the inclusion of marginalized people in the creation of technology and in the use of technology. This informs what we teach, both in the classroom and beyond the classroom. It also means that we have to recognize that the lack of diversity in the tech workforce right now both stems from and contributes to broader problems in our society, and we have to address these too. Secondly, we're really mindful about the impacts that technology has on the broader world. We have to recognize the potential harms that come with technology, whether that means harms to well-being or even exacerbating bias and inequality. At the same time, we're very involved in projects that aim to have a more positive impact on the world. We are collaborating with the Decolonizing Art Institute at UAL right now to try to surface and mitigate bias in museum collections across the UK. We have staff and students, some with disabilities themselves, who are making technologies that enable new ways for disabled people to interact with technology and create new forms of technology for themselves. And third, CCI is committed to creating digital entrepreneurship opportunities for marginalized people. If we want tech to be a force for good, we need to enable people to apply technology in ways that they're excited and passionate about, where they know technology is going to be useful. So this means applying creative computing to new application areas, to addressing needs in people's communities, and to affecting social change.
The Creative Computing Institute's public programme can be anything from talks, workshops, short online tutorials, conversations, and it's really aimed at engaging with the community outside of our students. Students joining it too, but it's very much for the general public. The reason I run it with so much passion is because it's a part of my ongoing research and practice, which is about including unheard voices in technology development. I think that we've got as much to give communities as we can learn as an institution from communities. And so engaging with the general public is engaging with users and having that dialogue, that critical dialogue, and then coming back and designing software and hardware from a more informed position is really important. I would love to tell you a little bit more about TechYard. It's a huge part of the CCI's public programme, and I've been running it for almost 3 years now. So it started in the pandemic as an online tutorial course for young people, and now it's grown into a hybrid programme. We go into schools, we run workshops here at the CCI, we collaborate with galleries all around London and hopefully soon beyond. And again, it's the ethos of engaging people outside of our student cohort with the critical creative computing conversation, ethics, and of course, like skills as well, right? So we can run 3D modeling workshops, virtual reality workshops, and we work with beyond young people now. So I do loads of stuff for young people, but also done some work with adults as well. Examples of past public programme workshops that we've run include inclusive design in wearable technology, designing a feminist chatbot, and queering voice AI trans-centered design.
I hope what you just heard and saw got you excited about joining us here on CCI. But now it's time to start talking about the two courses that you're here to hear more about, the MSc Computer Science and MSc Data Science and AI. So I'm very happy to pass on the mic to my colleague, Dr. Vali Lalioti, who's the Director of Programs at the Creative Computing Institute, and who will share with us a little bit about the approach, units, and content for the both MScs. Hello, Vali.
Hello, Georgina. Thank you very much. Hello, everyone. It's exciting to talk to you about the MSc in Computer Science and the MSc in Data Science and AI today. I'm Vali Lalioti. I'm just sharing my screen now. Bear with me. Apologies for this. I'm trying to change my slides. Very good. Okay. So I'm Vali Lalioti. I'm the Director of Programs for the Creative Computing Institute, and I lead the current 9 programs together with the academic team. The current 9 programs that we are running we're running currently, and then I'm excited because we're starting in 2023 in September next year, 6 new programs, and we're here today to talk about 2 of them, the MSc in Computer Science and the MSc in Data Science and AI. I also come from a multidisciplinary background. I have a PhD in computer science, and I started my career in computer science back in 1996 when working in the early systems of virtual reality, projection-based systems, first in Germany, in Fraunhofer Institute. And then I was fortunate to be a professor of computer science in post-apartheid South Africa during the Mandela years. So you will see some photographs there from the Belle African painting, making it into virtual reality back in 1999. Then I returned back to the UK, where I've done initially my PhD, and worked in the BBC, bringing some of the first augmented reality productions into our screens and getting awards from the Royal Television Society back in 2003. I got into more physical computing and robotics when I was doing my MRes in design with the Royal College of Art. And this is just an example that was picked up by Wired magazine of one of our projects. I continue to date working in this dual multidisciplinary way, both doing virtual reality. This is an example of a system that I developed during COVID to allow performers that were locked, like everybody else in our homes, to perform from their home as if they were in a real concert hall and with the acoustics of the concert hall. And that continues into funded research and projects. I also continue, for example, with work that follows and gives back to the community. This is work that we've done with the Royal College of Music. During their percussion festival, we got 1,500 young musicians to play in augmented reality with some of world-renowned percussionists from around the world in that virtual environment. On the more physical computing front, on creative robotics, I was a visiting professor in the University of Tokyo this year for 2 months, and creating some exciting new robots and exploring how we can design movement from the perspective of multiple cultures. But coming back to what is CCI? Well, CCI definitely have people like me and my colleagues coming from multidisciplinary backgrounds, working in that exciting merge between computing skills and creative skills. We are the first one of the 4 institutes, the first one to be created at UAL. Our purpose is to work at that intersection of creativity and computational technologies. We are the way that UAL explores technology and how is technology shaping our world. And at CCI, what we do is that we equip you with the knowledge, the skills, and the critical perspectives that will allow you as the new generation of talent to shape the world through your practice. So we will explore computer science, creative practice, and through very innovative courses. And our pedagogy is very important because it's very hands-on. It's team learning, it's experiential team learning, where you learn the core computer science and data science and AI skills through making, through programming, through doing projects, as well as, of course, the theories behind them. You've already seen from our video that we are very rooted in research. We're very research intensive as a research institute. So especially at a postgraduate level, you will benefit very much from the expertise of our academics and professors in areas like machine learning, data science and AI, human-computer interaction, virtual and augmented reality and extended reality, physical computing, creative robotics, and finally, and quite importantly, you will develop a critical eye and critical perspectives in terms of the application and the impact of technology in our society and digital citizenship. Our social mission is extremely important, and I want to enforce here this that this program, and if you join us in your postgraduate studies, you will be involved in this, both in your curricula, digital inclusion, diversity in technology, and digital entrepreneurship. They're all embedded within your learning. But also you will have the opportunity to volunteer, join us, attend some of the public events that we do along this social mission. I would like to go into more detail about the courses. So I will show you in a diagram, and I appreciate that that is quite a lot of information, a lot of small text to absorb. So I just want to show you this so that you get a feel for the structure of the units and the program. So for the MSc in Computer Science, you will have 4 terms. Your first 3 terms are taught lectures, while the last, and projects, of course, while the last term is about doing your thesis, doing your own research project. The way that we structure our courses are working in units that run across the first 3 terms. And you will see there are 2 layers here. The one which is blue, for those that color works, it's the top layer. And there you're going to be learning things like algorithms and complexity, cybersecurity and the futures of that, and computational ethics. So these units, they allow you to have a critical eye, to build a critical perspective, understand how maybe cybersecurity will affect us in the future, and bring in computational ethics and look at what computer science does for society and how it shapes society. On the units that are right underneath, which is an orangey color, the second layer, you have the core skills of computer science. So there will be advanced data structures for AI, advanced software engineering, and computational entrepreneurship. So these are together, they form the core of computer science teaching. And then finally, when it comes to the summer period, you have a break and self-directed learning, and you do a thesis project, which is your opportunity to integrate all the learning from the first 3 terms and also get to the direction that you want to go, supervised, of course, and mentored by our amazing faculty. You would expect something similar for data science and artificial intelligence. And indeed, the structure looks almost exactly the same, other than the units, of course, are different. So, for example, you will be getting the core skills, which is the lower level, the second layer, about advanced mathematics and statistics on data science, as you would expect is necessary for such a postgraduate advanced degree. You will be learning in the second term artificial intelligence and machine learning, and finally computational entrepreneurship that looks into how is the industry incorporating data science and AI, and also what kind of entrepreneurial perhaps opportunity exists for you post this degree. The top layer, again, gives you some of this critical understanding of the history of data science and AI, of the algorithms and data structures that are used, and how people and society and data interact with one another, and any ethical issues around using data science and AI in society today. So finally, you get to do the thesis project, and that's for the summer period. And it's another opportunity for you, again, to integrate your understanding, your learning from the 3 terms, and finally present that in a final thesis project. Very exciting, of course. After that, you have the opportunity to show your work in our postgraduate show and any public events that we're doing. These are just some examples from last year. And some work that also our academic staff are doing. This, for example, is making music through AI, where musicians and the CCI have combined forces together with the Alan Turing Institute to create an exciting program of music and AI performances. Finally, something else that we are preparing, and every now and then we run symposia. We have one coming up on the 20th of January, which is specific for creative robotics research, and others to follow. As I said, a lot of public events and a lot of opportunity for students to engage in your research field. So I'd like to thank you very much for this, and I'm really excited to answer questions. This was just introducing the course, and thank you very much for listening.
Thank you, Vali, for your super insightful presentation. Thank you so much. Now, I would like to welcome our colleague, Professor Rebecca Fiebrinks, Professor in Creative Computing at CCI, to this virtual space. Hello, Rebecca. She will give us a presentation about research on data science and AI with some related examples. Rebecca, the floor is yours.
Thanks, Georgina. So, let's talk about some current and recent data science and AI research happening here at CCI. I want to start out by just showing you that CCI is, even though we've been around only 4 years, filled with people who are doing world-leading activities, especially in creative machine learning and data research. So just to read off a few of what I've got here on the screen, I'm the first person who made an interactive machine learning application aimed at creative industries. And that was back in 2009, before machine learning was hot and neural networks were hot like they are today. I've taught the first MOOC online course in the world devoted to creative machine learning back in 2015. We have staff here who've made video art produced by deep learning, the first in the world purchased by a major museum, some of the first commercial quality deep learning audio generation happening in the world. We have the first UKRI, UK Research Council funded project exploring deep learning for generative media, and lots of other firsts that I'm going to go through in these next slides. Now, research in AI and machine learning at UAL has to date fallen into about 3 different categories. The first I'll describe here is developing new ways to use AI in creative practice. Now, this is work that isn't just taking off-the-shelf AI tools and saying, hey, how do we use these to make art? This is really pushing the boundaries technically, developing new types of algorithmic and computational techniques, as well as pushing the boundaries conceptually, not just making cool little toys that might be fun, but doing really serious art that's been shown in major exhibitions around the world. One of the alumni of the CCI ecosystem, someone supervised in his PhD by Mick Grierson, who's going to talk next, is Memo Acton. He's really well known for computational art using all sorts of techniques, but he's really been a world leader in his PhD work, understanding how we could use deep learning in new ways to produce new types of art, and actually how to build new deep learning systems for art themselves. I'm going to show you a quick clip here. This is a real-time visual instrument that Memo Acton made. This is really shortly after machine learning techniques like pix-to-pix, image-to-image translation came out. He was able to build a real-time system, a really important accomplishment a few years ago, where you could move things around in front of your webcam and the computer would do its best to recreate those images as the types of images in its training set. So here you can see it's being recreated as ocean and seascapes. Here it's being recreated as flames. And then here it's being recreated as flowers. So this is a really lovely visual piece, a fun interaction, and technically, again, pushing the boundaries of what was possible at that time. Terrence Broad, also a PhD student of Mick's, is now hired here as a senior lecturer, so somebody you might encounter if you came to study here. He's been pushing the boundaries not just of making new kinds of art with AI. He did the Blade Runner auto-encoded piece that you see here in the middle, which has been shown at the Barbican and the Whitney, an early piece of video art using deep learning. He's also done some really interesting new experiments with something he calls network bending, where we're manipulating neural networks in new ways. And he's made some really interesting informative and educational tools that help people understand what deep learning networks are doing. This is a screenshot from a master's thesis by a student I supervised, Nan Zhao. She's Chinese and had a really big interest in how we might use deep learning to create new forms of engagement with cultural heritage in China. And the pictures you see here come out of number one. She developed some deep learning generative techniques to recreate new Chinese cave paintings from ancient Chinese cave painting images, but also she embedded this in a sort of fun system where you can take a selfie and translate your own face into the style of these cave paintings. This video I'm going to show you here, these are images from a collaborative work in progress by a team of current CCI staff. They're using text-to-image diffusion models, which of course are getting a lot of attention right now, but they're using these models in slightly different ways. They're not just typing in some text and saying, oh, here's a cool picture. They're actually using machine learning models to act as a critic, interpreting the images provided to it and allowing that to shape the unfolding of the work. Mick Grierson, who you'll hear from next, worked with Massive Attack to actually remix their Mezzanine album in work that's been shown at the Barbican and around the world. And my postdoc, Gabriele Vigliansoni, is both an active musician and a machine learning researcher. He's been building a variety of new deep learning and shallow supervised learning systems to explore how we can generate new musical audio and control it live using gestures. And he's especially interested in how we can tweak conventional approaches to machine learning so that they better represent music from Latin America, Africa, and certain types of electronic dance music, which have more complicated or different types of rhythms than those that are usually represented in the AI systems being developed. Right, so that's what I have to say about using AI in creative ways. Another really strong stream of our work here considers how we can make AI usable, especially to people who aren't computer scientists. So the works that I showed you saw a lot of, they require a lot of technical expertise and innovation. These require understanding and changing the guts of how machine learning algorithms work, building new implementations that work in real time, understanding and manipulating really complicated data streams coming from video or music or human motion. And we're all interested in the question of, well, how might we make these advances beneficial and accessible to other people, whether that's professional artists, students, people with disabilities, or other sorts of groups. So we have a lot of open source software, for instance, that we've made and published. My software, the Wekinator, was the first interactive machine learning tool for creative practice. It's been used by creators around the world to create new musical instruments, live performances, and interactive art, with about 50,000 people using the latest version. It's also used in teaching around the world at a lot of different universities. The Mimic platform, which came out of a project led by Mick Grierson with people all around UAL and some other institutions in the UK. One of the outputs of this project was a platform that you can go to right now at mimicproject.com and actually use your browser to use AI to make music and art. This has also been used in a lot of teaching, both at UAL and in MOOCs that have been taken by tens and tens of thousands of students. With Phoenix Perry, a game designer, interactive artist, really phenomenal thinker, I've contributed to this additional tool called Interactimel. This is for Unreal and Unity game engines. And this was designed to allow game designers, VR designers, and people doing interactive art to use machine learning in new ways, whether that means making new kinds of gestural interactions with game engines or making new kinds of game mechanics in which the world might change according to different data streams from within the game or outside the game. I've also been involved in a project called Sound Control, where we built a machine learning tool with and for kids with disabilities, as well as their music teachers and therapists. This tool allows people to make new bespoke musical instruments that not only use gestures and movements that are comfortable for the kids to use, but allow them to play sounds that they really enjoy. The third stream of research that I want to finish up with here is research around changing society for the better. This is a real strong interest of many of us staff at the CCI, as well as many of our students. In the video earlier, I mentioned the UAL Decolonizing Arts Institute project called Transforming Collections. CCI personnel are working really closely with them to design new machine learning tools for use by art historians and archivists and curators, as well as artists themselves, with the aim of making it more possible to surface bias in collections around the UK, to mitigate that bias, and to develop new ways of understanding art in our collections. In addition to having research projects that are specifically focused on changing society, a number of our staff are involved in shaping policy in the UK and beyond. So for instance, Mick Grierson has been very active in calling for a UK Centre for AI in the creative industries, influencing government policy around how do we allocate money for tech and for the creative arts and beyond. Other staff are involved in activism around AI and data, for instance, helping to produce reports like this one from the organization No Tech for Tyrants. And of course, part of what we do at CCI here when we think about changing society is to think about how we educate, who we educate. We're really committed, of course, to doing excellent initiatives, excellent work with our students internal to UAL, but we do more beyond that as well. So we've made a number of online classes, for instance, this one, which provides an introduction to creative AI, which is really accessible to lots of people, not just people coming from strong computer science backgrounds. And this MOOC, which is focused on engaging in activism for social change in technology. So I'll leave it there.
Thank you, Rebecca, for your presentation and for showing us these super exciting projects. Now it's time to welcome my other colleague, Professor Mick Grierson, research leader at CCI, who will walk us through some more research on the field of computer science this time. Mick, the floor is yours. Welcome.
Thanks so much, Georgina. I hope everyone can hear me okay. So I want to talk about specifically computer science research that's been happening around the Creative Computing Institute and things that staff and students here have been doing in computer science. But before I get into the weeds on that, I want to talk a little bit about what computer science is, and just to kind of try and focus a bit on how it's distinct from other things, and why certain kinds of research happens in computer science that might also you might think might happen elsewhere. So, and I guess one way of defining computer science is that it's a branch of science that tries to work out what you can and can't automate, asks those questions about what can be automated and what can't. This is a really interesting way to think about computer science, because it gives you, perhaps often someone will say, well, what's the point of this? And then, what's the point of, I don't know, let's take the Transforming Collections project, where we're trying to create machine learning systems that people can use to service bias in collections. People might say, oh yes, but what's the computer science question? And the computer science question is, what of that can be automated and what can't? And a lot of that's to do with the context, how the information is treated, how the information is privileged. So these are still the core questions of computer science that you address when you undertake research anywhere, and particularly at UAL. So it depends on a lot of things, what can be automated, this question. So specific tasks and processes, specific kinds of computers, and who is using those computers. All those things really matter with respect to those questions. So in some ways, computing research can just be about computers, right? For example, how can we change the way computers are created and used? So that's a straightforward computer science approach. That can include how and why we make computer hardware a certain way, or how and why we develop software for any particular purpose. But it can also be about the way computers are impacting how we approach science outside of just the operation of computers. This is sometimes called interdisciplinary computing, which is a very, very important form of computer science, one which is becoming more and more important at many institutions, but which has always been important to us. People often think that this is just a form of, they think of it as an applied computer science. And part of the problem with this is that computers are almost everywhere and used by almost everyone. And so that means that almost the majority of people, when they come into contact with computing in terms of, and to try to understand, let's say you want to understand what can be automated, that means that almost all of the applied computing is where the action is. So the way we understand how people use computers can change the way computers work. And just as an example of that, let's just look at the iPhone. So in terms of core technology, there are some big differences, but in general, the way that the device on the left, the iPad, is designed, and the core touchscreen technology, the use of home buttons on the bottom, the configuration of speakers, and some of, not all, but some of the features of that device are largely similar to the device on the right. And you could ask yourself a question, well, what is it that makes the device on the right so successful? Why did that revolutionize the way people use their phones and use media and have devices? Right now we have, everyone has one of these things in their pocket, either one like this or designed almost exactly like it. And so what were the differences? Well, one of the big differences was that it gave very, very clear physics-based animation feedback to users that helped them understand what was going on the screen, which the device on the left never did. So there was something about the way that the system was developed and the way it allowed users to interact, which supported their understanding of what was going on in a different way. So that changed where computers were used, what those computers did, and why they did them. And it's to do with the manner of interaction. The core technology might even be the same. So that brings me on to this question of creating accessible platforms. This is a really important part of computer science, and it's becoming more and more appreciated as time goes on, particularly when you think about web accessibility. Often, we might use an approach called co-design or co-research to do this. And co-research is really interesting because it allows us to, for example, understand what it is that people could do with computers if we gave them a chance. Sometimes a computer system is just so far, it has all of the design put in before it's shown to anybody. The problem with that is then those people just don't do what you expect. Now, we spent quite a lot of time working with users, actually working with community organizers who are disabled, learning disabled and autistic communities, to design new technologies which they can use to conduct their own research. And we did that funded by the Wellcome. Millions of pounds went into this project, funded by the Wellcome Trust, to develop technologies so that learning disabled people and autistic people could run their own research projects and collect data and also reason about that data. It's a really important project which is now supported by the Health Foundation and has led to a training training course with NHS practitioners and NHS leadership in terms of how communication happens, using technologies. Other projects which we've been doing in similar areas, they might actually just allow a different way of seeing something. So Katie Wolf, who's one of Rebecca's PhD students, has been exploring new approaches to data sonification, including real-time sound remapping. So on the left-hand side here, you can see this white box, which is which demonstrates a mechanism which Katie's made available for people so they can map their Twitter feed to different sounds. It allows them to, it's not just as simple as a ringtone. This is about creating a way to imagine what's happening in the social media environment, but through your sound experience, and allow you to decide what that should be. And on the right-hand side, we have something which is much more for a live experience, where someone is standing in a room and any audience member can change the sounds which the musicians are actually making, can create or modify sounds which are being used as part of performances. Another of Rebecca's PhD students, Reid Oder, produced this amazing system for latency-free musical collaboration over the internet. Now you can see there's a chart here. What's actually happening is that the webcam is detecting when someone is going to hit a drum, for example. And then it's predicting when it will land, when the actual strike will happen, and then making it sound earlier for the user on the other end. So two people over the internet then can have latency-free musical experiences, because it takes time. The round trip time is too long, so you can't play in time. This allows people to play in time by predicting when a drummer will actually hit an object. It's a brilliant system. One of my students, Pedro Kirk, he's been working at UCL Hospital to support people who have had upper limb stroke. So when you have stroke, sometimes it can really affect your upper limbs. And there's a whole team led by Nick Ward at UCL, actually led by many people. Nick's one of those people we collaborated with. And the way that you recover depends on how much repetition you can get into your exercise. Using music in this way is quite cool. So what you can do is you can use that music as a motivator. And what we actually had was a bunch of detection mechanisms that can be trained and set up by a nurse who understands the needs of the patient, so that when they're doing exercise, music plays, and when they make a mistake with their exercises, if it's not quite right or if they stop, then the music stops. And you could do this with the TV, you could do this with all kinds of stuff. And this helps people stay on target. Another piece of work which is interesting is with writing. So you can see here what we have is, you may have heard of something called style transfer. Style transfer is a way of taking, a piece of work and making it look like another piece of work. Here what we've got is a piece of writing in the middle. On the left-hand side, A is a piece of writing, and then we have a prototype piece of writing in the middle, and then you can transform one piece of writing with the other piece of writing to get C, which is this new version. So you can, for example, use this to change the style of your graffiti, or to modify or apply different graffiti styles given an actual human gesture. And this is done by modeling human movements. It's not just analyzing the image, it's modeling the movements that are being made when the writing is happening. That's by Daniel Berrio, who's a really fantastic researcher. Terence Broad, you may have heard of him already in this talk and perhaps before, who's now a CCI lecturer, did a paper with me, which we presented at SIGGRAPH many years ago, not too long ago, basically thinking about how you could take new forms of depth images that are used to create photographs that have 3D capabilities, and then do what we call in-painting. So extract errors and replace them with in a way which maintains the coherence of the 3D environment. Not as easy as it sounds. Tamea Farkas, who is another one of Rebecca's PhD students, has done this fantastic work understanding how players are describing immersion when they're working on a board game. And this is something which, what's being automated here is this process of understanding, or what the kind of technological intervention is about trying to understand people's experience of board games. There's a different way of thinking about games and the impact computers can have on games. And it's really fantastic. And Tamea is already working at a research company that focuses on board game design. So is using that research in the wild right now. So Areti Aloy, another of my PhD students, she did a fantastic project working on visualizations in live context. So when you go to a gig, you see a massive projection, or if you go outside and you see people using big LED screens, how are people creating that stuff? Areti found that when she built these systems for people, they often said what they really wanted was more information from what was happening in the soundtrack, so they could apply that to the image track. And there was such a call for this that she prototyped a range of different approaches for getting information out of soundtracks in real time and using them to change the way the image looked. And her PhD in that topic is absolutely fantastic. Other things that we might do is creating entirely new types of interfaces for people who, for example, don't have fine motor controls. There are quite a lot of people who, for various reasons, they find it difficult to use, for example, a touch screen like an iPad. People say iPads are really accessible. There are times when it's not. So, for example, if you're a non-verbal autistic person and you haven't really ever used a pen, it can be quite hard to control your hand if you've never done it before. So we built systems to take advantage of your ability to squeeze and to move a dynamic mass. With a researcher called Dr. Chris Kiefer, who is a lecturer at the University of Sussex. We built a system which allowed people who didn't have any other means of communicating to communicate via an iPad, but instead of using the screen and using the iPad that way with a finger, they would use this tactile device, which isn't just an on-off, it's a multifaceted device. So one type of squeeze means one thing, one kind of squeeze means another. Another thing about computer science research that we're involved in is creating new programming languages and platforms. Trying to understand the way you program is important. Programming is part of what we do. It's not the whole story, but we can't often do what we want to do without programming. Now, the way we teach and understand programming is kind of essential. The way that programming languages are structured can change the way that you understand and also the speed with which you can create new types of systems. So we've done quite a lot of work with that, building new interfaces for programming, and we've used those in education as well, because that's primarily what we want to do, or to help people become better developers often. Not always, but often. And you can see here that what we found is people who experiment more in real time make more mistakes, and as a result, produce better quality work. So making mistakes quickly, in our experience from monitoring people using our platforms, and getting great feedback on those mistakes very quickly leads to better results. And finally, we've done quite a lot of work and continue to do a lot of work over the last decade in VR and XR, as many people do. It's a very hot topic, but it's, struggles to, I think there are two problem areas. One problem area is people don't like putting those things on their heads. And another issue is that, for example, it's quite difficult for people who want to make VR experiences to make them. So 4i project was funded by the EPSRC, and UAL were a partner on that. Rebecca and Phoenix worked on that project. It's a great project, really good outcomes, including Interactor, which Rebecca was talking about. But another thing we're working on is how to make it easier for people to create VR worlds without having the kind of currently required level of programming expertise. So this is about building an interface which allows people to collaborate in real time to make VR and XR worlds. And it's super easy. We've been testing this with our collaborators in Ukraine. So this is as part of this project. A war broke out in the middle of our project, and we continue to work with these people remotely with our colleagues at SUMI and elsewhere in the Ukraine and in Poland as well, in order to understand how we can support specifically people who are in the creative arts and media and television to build really fast VR prototypes interactively together without having to know how to program. So we built that platform for them. And so hopefully that gives you an idea of how the key questions of computer science to do with automation and what can be automated, and other questions about why computers should be the way they are, in what context they might be relevant for people, how people transform computers. I hope that gives you an idea of why we are different, what makes us unique, and why we think MSc Computer Science at UAL is going to be special. Thanks very much.
Thank you, Mick, for your introduction on computer science research and for showing us these brilliant projects. Now we've got around 7 minutes for the Q&A, and I will invite again Vali, Rebecca, and Mick to join me here, and we'll be going through a couple of frequently asked questions. In this section, we also encourage you to send us any questions, queries, doubts that you have about CCI or the two courses that we're gonna be covering now. And yeah, just engage with us so we can, answer your questions about the two MSCs. So we could start with a very important one, which is about the application process. And we get, of course, this question a lot. How does the application process work? So Vali, would you like to cover this one?
Yes, of course. It's a very important process, isn't it? But it's a very straightforward process as well. First of all, you go online, all the links are there. You go through the UAL application link. And what you need to do are two things. You need to put your CV in, and you need to put your statement. And the statement is the most important piece that you will write about your application. And you need to communicate to us why you want to do this degree with us, what background also you have, any experience you have with either computer science or data science and AI communicated in that letter. And there is a lot more information also about specifically how to write that statement and what needs to be in there. That's all you need to do. So what happens in the back office on our side is that the applications team receiving these applications, they are checking your qualifications, they're checking if you meet the entry requirements, and then they pass on your application to us. So we're going to look at your CV, we're going to look at your statement with very much with interest, and to understand what makes you want to come to us, what specifically you want to research maybe, and what background you bring for this course. Then we do that, and that process happens also online on our side, and we pass that information to the applications team again, who communicate with the successful applicants, they communicate the outcome of the process, and then we welcome you in September 2023 to the MSc Computer Science and MSc Data Science and AI.
Thank you, Vali, for going through the process. Super helpful. Right. So another question that we receive very often as well is, what is the difference between data science and computer science at UAL and elsewhere? What makes these two courses at CCI so unique? Who would like to answer this one?
I can have a go.
Go for it.
So I worked in traditional computer science departments, and it's definitely something I know pretty well. And I think there are big differences between what UAL, Creative Computing Institute, is trying to do and is going to do and is succeeding in doing, and what is happening almost everywhere else. And that's because we have a totally different perspective about what we think computing should be about. And it's like I was saying earlier in our presentation, this notion that of what is valuable is somehow kind of at stake. And I think that people have these ideas about what they think is good computing research, but when you look at the way people use computers, often that's not present, and often there are concerns about what some academic institutions think might be valuable computer science research over other kinds of research. So let me give you an example. Without highlighting any particular departments, because they're great at what they do, but there's often a focus on areas such as surveillance or military applications, or kind of fighter aircraft navigation consoles and things like that. Now, I understand why that's there. We all understand why that's there. Our argument isn't that people should not do those things. Our argument is why is it that we're focusing on those instead of other really exciting and important things, such as the way people are using computers to support their values and their own beliefs, how computing can help transform society by providing and automating tasks which otherwise they would have to do for no reason. Like these sorts of approaches, it's fine. We're not saying that all these other computer science departments that are focusing on these things that people think are important, killing people, etc. We're not saying those people need to, they obviously are not going to listen to what we think anyway. Our approach is, I just want to reinforce this, our approach is absolutely, totally antithetical to that. We are trying to create, we have succeeded in making a stream of computer science, a way to consider computer science, which is totally oppositional to those kinds of values right at the very core, and is much more about the way that we apply it in human context, how we support people in society, how we can improve the way the voices that people have in society, support that and automate processes, and with them leading what should be automated, play into ideas that are completely different, that have a creative center, a social center, which are more about people pulling together and being a community. And these aren't political issues. These are just about people. And that's why human-computer interaction is so central to what we do, but also why being at UAL to do this is the right place, because UAL as a kind of the biggest creative university in Europe has a kind of perspective that feeds from all of these different parts of society. So, I think I've said quite a lot about it, but just to say, I think it would be it's a different way of doing computing, which is really important and is entirely unique in the market.
Thank you, Mick, for your answer. Beautiful. So moving on, we've got a couple of questions from the chat, which we're going to be covering before we finish. So Patrick mentioned, just wondering why the degree program is targeted at the creative industries. Vali, would you like to cover that one?
Yes, thank you. Hi, Patrick. Interesting question. The program per se is actually targeting the more broader industry of computer science and data science and AI. We're using creative ways to teach you computer science and data science and AI because we know that these work very, very well. We're running 9 programs at the moment that are successfully taking people that don't have knowledge in computer science, or they have knowledge in one or other subfields of computer science and data science and AI, and taking them out into all kinds of different industries. To give an example, our graduates from programs are really highly valued in technology-intensive companies like IBM and Google and so on. And they are valued because they have that understanding of creativity and computer science. And they can talk and lead projects that incorporate many different talents and multiple disciplines. And that's the uniqueness of our program and the uniqueness of becoming one of our graduates in computer science and data science and AI.
Thank you, Vali. Thanks for your answer. And the last question that we're going to be covering now is the following one. Is it possible to do a subject knowledge enhancement on programming maths? Who would have an answer for this one?
I can try and give it a go. I'm not very sure. I'm not really sure if I get the question right, but I guess it is about whether you can do an additional. So is this, I'll answer it in two ways. First of all, maths are important to both courses. So if this is about, can I do some additional maths if I need to, to supplement the course that I'm taking? Yeah, obviously. And we have seen in the past, so there are tutorials, we provide a lot of materials also online, and sometimes we're looking at organizing summer camp courses for students that feel that one side or the other might be lagging behind, that being maths or coding, for example. If that was the question, if it is something else that you meant by that, then please type it in and I will try and address it.
Thank you, Vali. Beautiful. So we made it to the end of the session. Just wanted to give you a big thank you for joining us today, everyone watching. If you have any other questions, we invite you to email us at cci@arts.ac.uk. We're going to just put the banner on the screen so you can take notes. Let me just find it here. Beautiful. Here it is. So yeah, feel free to email us with your question. Just being conscious of time, we won't be able to keep any other questions going. But yeah, our inbox is always open for you to email us and we'll happily get back to you. And we also invite you to follow us on social media. You can find us on UAL_CCI, and there we'll be posting about our upcoming events, opportunities, workshops, and different ways of engaging with our work, our research, and our teaching programs. And finally, just a note to say, we're looking forward to meeting you in real life and to hearing from you if you have any other questions via email. Thank you so much and take care in the meantime. Bye-bye, everyone.
Thank you.